we have some exciting new features for you in V23 for the civil survey and mapping industry that I'm excited to show you. And to start off with, first of all, we have a civil workspace. So when you launch a product, in the launcher you'll have an option to select the civil workspace. You'll also see it here in the list of other workspaces, but you can see on the Home tab it really prioritizes the civil tools that we have. So you see options here for working with tin surfaces, working with alignments, and so on. One of the features that has been a big request for quite a while is the ability to import and export shapefiles. This is really just the beginning for us working with this type of data. In this version, we have the option to go to the GIS button on the ribbon and pick GIS Import. We can browse and pick either one or several shapefiles all at the same time because each shapefile will only be one single feature class. And in the GIS Import dialog box, we'll see that we have a row for each one of the shapefiles that we selected and the file name at the beginning. You can change your mind and toggle these on or off if you don't want to bring in all of them. You have a column for the feature type. This is also read-only. It is just showing you that the particular file in this row is either a polygon, line, or point. And then we can select what layer this is going to be created on. So I can select that field and I can pick either an existing layer out of the drawing that may already be there. I can create a new layer, or I can create a layer from a field of data. So for this example with parcels, I can go down and pick zoning. What it's going to do is place the polygon for each parcel on the appropriate layer based on the zoning value in the GIS data. Of course, you need to know what those values actually mean. They may be somewhat cryptic depending upon the data that you have. I'll pick OK for that. And for the streets, I'll just put them on a layer called roads. It currently shows us the coordinate system that was assigned to these shapefiles if they were assigned one in ArcGIS or ArcView. If you don't have a PRJ file that comes with your shapefile, this would be blank. In this version, we currently do not support converting coordinate systems. That's something that will be coming soon. Also, we have a column for GIS data. This allows us to pick if we want to import the GIS data or not. It's going to automatically, by default, be imported into a GIS data table that is stored inside of the DWG. So no file management, it's all part of the DWG file. Now I'm going to leave these turned on to bring in the data. And then finally we have a column for elevations. By default, it's going to use elevation 0. You could type in a different elevation value for this. If it was a 3D shapefile, we could have it read from the geometry file, or you can also bring in the elevation data from a particular field in the GIS data. This is particularly helpful when you're bringing in a GIS file that contains contours, because often those contours are all at elevation 0, but they have an attribute value for the elevation. You could just map it here and elevate the contours automatically. Then we have the option to specify an import area. I'm going to use the default of all, but you can see we have options here for a clipping polygon or to draw a polygon. So you can either draw it right now during the command, or you can select an existing polyline. This is, again, very important if you have very large data sets. You might have the parcels from the entire county or several square kilometers. You may not want that all to be imported because you only care about a certain area in the file or in the drawing. You can clip this down and increase your performance that way. Once that's set, I'll just pick import, and here are my parcels and my streets. if I go to the layer dialog box, we'll see here that we have all of these layers that are named differently, like CC, CI, E30. These are zoning designations because remember, when I imported the file, it actually asked me, or I told it to use a particular value out of that shapefile to assign the layer name. And we picked the zoning value. So these were zoning designations. I can go to roads and maybe just change the color to red so we can see the roads stand out apart from the streets. If we zoom in and take a look at this, I could pick any one of these lines or polylines that makes up the street. You would see in the properties, it's just a regular CAD line and all of its geometry. But at the bottom, we have an area called GIS. And if I expand that, it shows me all of the values that it imported from that shapefile. And these are all editable. So I could make changes here. For instance, if I wanted to change the speed on that road from 25 to 95, we could do that. That has updated it here in the drawing. It has not changed it in the shapefile. We could, however, export this data to send it back in its updated state to our GIS system. Same thing with any of these parcels that I select. If we scroll down to the bottom, we'll see it's just a polyline. And here's the parcel and all of its data. And here we see the zoning is LD, which we'll also see matches the layer name because of how we did the import. So you can start to see how just by doing the import, you can do some very basic and crude thematic mapping by assigning objects to different layers and then different colors to those layers to change their color or line type. Currently, we do not have the ability to create our own GIS data tables. In BricsCAD, we have to import them from a shapefile. That is another feature that is coming at some point in the future, fairly soon. We also don't have the option to assign new data to new objects that we create in BricsCAD. Again, something that is coming or on the way. The last thing that we can do with the GIS functionality right now is export that back out. So if I go back to my layers, I'll actually just turn off or freeze the roads. So we're only selecting the parcels to export them. When I go to GIS and GIS export, it asks me to select the entities I want to export, and then just simply to give it a file name. So I'll call it parcels, tell it where to save it, and that will create the shapefile that we could hand off to our GIS department or anyone else who wants the shapefile data. Currently, this just works with shapefiles. We will have additional GIS formats coming in the future as well. But a very significant start for us and a great option for our users to access a lot more data. So moving on from the GIS data or the shapefile import export. Another thing that is really important that we've done in the interface is we've added the Civil Explorer. And this is a drawing with a lot of civil objects in it. And we can see here in the Civil Explorer that I have several point groups, and it shows me these 3 different point groups right here in the tree view. I can right click on them and do things like zoom to these points, select them, and so on. We can also see a large number of surfaces, and I could go to any one of these surfaces and right click and again select the surface. I could start doing surface edits, and we'll look more at the surface features in just a few minutes. But same thing here for alignments and so on. And this is an area, again, that will be expanded and built out more moving forward. Now to see this in action, if I go to a drawing that just has some AutoCAD points and AutoCAD 3D polylines, or CAD points and CAD 3D polylines within it, so that we can build a surface out of that. All I would need to do is go to Tin Surfaces in the Civil Explorer, right-click and pick Create. And I'm just going to select all the objects that I want to use to build the surface. And BricsCAD is smart enough to look at this and say, when I pick these objects, that there were several linear features in here. And do I want to use just their points or their edges, or do I want to treat them as break lines? I'm going to treat those as break lines. And it goes out, builds a surface for me. We can see it here in 3D and rotate it around and look at it. We can also go back to Plan View. And if we go to Plan View and change our visual style here to 2D wireframe so we can see the tin a little bit easier, we can see the triangulation was done. We also can go under Tin Surfaces, and here we see Surface 1 in the Civil Explorer. And once I select Surface 1, down at the bottom half of the Civil Explorer, we'll start to see a lot of very useful information. First of all, I just have info, and here's the surface name. You know, I could change that if I wanted to be existing ground. I could just type in EG or a description or anything like that. Notice that updated up above. The really important tab is this definition. And here we see we added drawing objects and we added break lines. I could go back and edit these at any point if I want to, or change their order. One thing that I noticed is that the edges didn't get cleaned up in my surface. We didn't have a boundary, and we didn't do anything to stop it from triangulating outside of where we really should have data, like these areas. So we have a few options. I could delete lines individually, and we would do that just by right-clicking on the surface, going to Edit, and I could pick Delete Line. There's also an option to remove outer edges. And if I do that, at the command line it says, do I want to use a maximum triangle length? So just delete all the long triangles. And this will only work on exterior triangles. It will not delete long interior ones, which is really important because we don't want to cut holes accidentally in the surface. So I'm going to say yes, I want to use maximum triangle length. My length, maybe I'm not too sure what it is. Maybe it should be something like this. I'll just go pick it. Use minimum triangle length. No, I'm not going to do that. Or maximum angle. So I'm not going to do that one either for right now. And when I enter, I obviously picked a length that was way too short because we made a mess out of the surface. This is where that definition really comes in handy, is because I can go back to the definition and I can see here is remove outer edges. If I just double click on that, it brings up that particular definition that we added, and I can see I used a length of 40.000045 or something like that. It was too short. I can just change it right here. I could say, what's it look like at 75? Well, that's quite a bit better. I could try what's it look like at 100. And you'll see that it updates real time for me that quickly. So we can go back and make changes to any of the things that we've done to build that surface and update those on the fly. Now I could say maybe I don't want to use maximum edge length. I want to use maximum angle instead. So if I turn that off, you see they all came back. My maximum adjacent angle on the edge, let's say we want no angle to be greater than maybe 120 degrees. And you see that clean up the edges. So maybe I like that better, maybe I don't, maybe I want to turn that off and just turn the edges back on. So you can see how quickly and dynamically we could update that. If I don't like the remove edges option, I can always just right click on it and either just disable it and turn it off or delete it entirely. And that's gone. Maybe instead I drew a polyline that I wanted to be my boundary. And I'm not going to take time to be very detailed with this. I'm just going to say here is a polyline that could be the boundary of the surface. And obviously it's going to cut off a lot of my good data here, but that's okay. This is just an example. So I would right click, pick edit, add boundary. I'll just go pick that boundary, tell it it's going to be an outer boundary at the command line. And we're not going to trim, we're going to erase everything up to it. And there's my boundary. That again is dynamic, so if we stretch it around, you see how it updates. Now the other thing that I wanted to bring up here with that is this order of operations in the definition is super important because it works through this in order, 1, 2, 3, top to bottom. And for example, a boundary really needs to go in last, because if that boundary goes in first and then we add more data, that data doesn't respect the boundary because it's already been applied. So if I gave you an example of this, pick that add boundary option and moved it up to the top, you see the boundary didn't do anything. If I move it down one so that the points are in but the break lines are not when the boundary got applied, here you also see some not what we would really want, because some of the data, like those break lines, hung outside of the boundary. They retriangulated differently after the boundary had been applied. So really what we need to do is just move that all the way to the bottom, and that would update the way we want to see it. Other things that you'll see here in the Civil Explorer are statistics. Shows me exactly how many points, how many triangles, minimum and maximum and elevations, all just read-only values, but important data to look at with your surface, and something that if you looked at the minimum elevation and it didn't seem right at all, probably gives you an idea that you have some data that was incorrect and needs to be updated. The final button or tab here along that is visual styles, and you can see here we're looking at triangles. I could turn that off and I could turn on contours, and I could set my contour interval and color right here. I could turn that off and I could do elevation banding and show different colors at different elevations. And maybe I want to display it as triangles for this. Maybe I want to change the color to greens, and we go dark green to light green and different things like that. But a lot of different ways that we can view that surface. Same thing for slope analysis. I'll just turn my triangles back on to where we were before. So that's some real basics with the new Civil Explorer and some of the new tin definition features, which are really going to change the way people are able to work with their tin surfaces. Next, I want to show you labeling that tin surface. Here's another tin surface that just has contours shown in it, one of the things that we added in this release was some surface labels. And there's going to be a lot more work done with labeling, but for right now we can add surface labels, and at the command line I'm just going to tell it I want it to be contours. We can also do spot elevations and slopes. So you can do a grid of spot elevations or just pick individual places for spot elevations. With contours, it'll ask me what style I want to use for the major contours. I'll just use the one called default. For the minor contours, I'm going to tell it I want to use none. And then we pick the surface and just draw a line across that. And you can see it labels those. In the Civil Explorer, at the very top, you'll see it's set to object view. There's also a settings view, and this is where you're going to see settings, which include things like under surfaces, label styles, and contours, and you can create your own label style or edit an existing one that has come from your template. Finally, the thing I want to show you is really the most exciting one and the best one. If you take nothing else away from this today, this is the feature that is the big one for us. And this is the ability for us to build an optimized but yet accurate tin from a very large point cloud. You're probably aware that one of the big challenges in our industry is we can now collect massive amounts of data via scanners or drones, LiDAR data, bathymetric data, you name it. And the tin model, not just in BricsCAD, but industry-wide, was never meant to handle hundreds of millions or billions of points. So how do we weed down the number of points without losing the accuracy that we really need? And that's the challenge here. So I've got a point cloud already attached to this drawing. And this is stuff that we have seen in BricsCAD before, obviously. I can see here's my point cloud. I could go to that and look at any regions or classes that may be assigned to it. I could go to the point cloud tab here and change color map for this, maybe by elevations and by spectrum, so you can start to see, the high versus low areas within this. That's just standard point cloud functionality in BricsCAD. What we want to do is make a tin surface out of this. And this point cloud, just to give us an idea, if I pick it and go to properties, it has about 6.4 million points. So we probably could make a tin surface out of all of these points, but it would be really slow. If we were talking about 60 million or 600 million points, you probably couldn't make the surface at all. And if you could, it would be agonizingly slow. We're not talking minutes, we're probably talking hours on things at times. And anytime you have a surface that is too large, you're not just dealing with it at the time you built it, but all the way through the design process. Every time you cut a profile, every time you regen, every time you do a cross-section or a grading, it updates and it has to look at all of that data, and it's just not usable. So what we can do is, back in the Civil Explorer, just like I did with regular data, right-click on tin surfaces and pick Create. And I had that selected already, so I just built the surface. I want to delete that and do that again. I'm going to right-click on tin surfaces, pick Create, and then when it asks me what kind of data I want to use, I'm going to tell it to create from a point cloud. I'll then pick the point cloud and enter. And because it's a point cloud, it looks at it and says, do you want to simplify the tin surface? So here at the command line, I'm saying, yes, I don't want to use all these points. I want to simplify it. And it asks me to enter a radius and then an elevation difference. So what it's going to do is take all the points within whatever radius I set. So I'm going to use 10 as my default, and this is 10 meters. Everything within 10 meters that has an elevation difference less than, let's say 0.2. So 0.2 meters. Anything that's within that radius and the elevation difference between the points is less than that, BricsCAD is just going to skip and not use in the tin. It's not going to delete them from the point cloud. It's just going to not use them in the tin, giving us a much more optimized tin because these are points we probably didn't need. They're on a relatively flat area. So when I do this, and I'm not speeding this up, this is real time, it just processed through the 6.4 million points, and it found 89,400 that met the criteria that we want to keep. 89,000 is a much more reasonable number for us to work with. It then asks me if I want to create the tin surface or if I want to simplify again, because maybe I don't like those results. I could change the values and go through it right here. I'm going to tell it to create the tin surface, and then it asks me if I want to densify the surface. Now normally if I was in a production mode, I would probably go through and just densify a particular area right now because I probably know that. But because this may be the first time you've seen it, I'm going to say no, I don't want to densify yet. I want to look a little more closely at this and see what we're doing. So it finishes that. I'm going to go to the point cloud and just hide it to get it out of the way. But there's my tin surface built from that point cloud. Now if I go back to the Civil Explorer, I'll see here's my surface 1 under here, and if we zoom in and look at this in different areas, some areas it looks pretty good, but here's this road, and maybe this is the area that we're going to work on in our particular project. And you can see in those areas there needs to be a little bit more definition. Some of this does not look very tight for us, because when we simplified, the problem is that we told it to skip a bunch of points that were within a particular tolerance, but we didn't tell it which points to skip. So we can go back and densify this. If I pick my surface and go to definitions, just like we had before, you see it added points and removed outer edges for us automatically, and then created a snapshot for us. I'm going to right click on surface 1. I'm just going to tell it to edit, and that I want to simplify. Actually, it's not there. That's my bad. We have changed it since then. I can go to add point cloud back at the beginning. We consolidated this all onto one panel. So in the definition, we have the simplify that's turned on. We have the radius and the elevation difference and the results. If you don't like that, you can change them right here, just like you would change anything else in the definition. But I want to densify, so I'm going to add a new area. And I'll give it an elevation difference of 0.1. So within the particular area that I'm going to specify, it's going to go back to every single point in the original point cloud and find any of them that have an elevation difference from the surface greater than 0.1 and add them back into the tin surface. So this lets me do this on a localized area or areas. We can do more than one if we want to, because you're probably not going to be doing design work on this entire big square of data. It's probably going to be focused in a particular area. We can do that. You could even do it in really small areas like curb islands and things like that. So I'm going to say use that elevation difference, and I can either pick an existing polyline or I can draw one. So I'm going to pick draw polygon, and I'm just going to pick somewhere out in here. Call that good. Let it go back and reprocess the data. And when it's done, you can see already when I hover over it how much tighter the triangles are in that area. You can also see how much better that roadway looks through that area where we have densified it. I can even check this box that says show the area, so it shows where we've densified as well if I want to. Now I could go back and I could change that elevation difference if I wanted to. I could add new areas, I could delete that area. The point being, you don't have to just throw this out and scrap it if you want and start over if you don't like your results. We can go through this in a very iterative process. So if we come back out of that, maybe I want to see it in plan view as well. Yeah, it's pretty easy to see there. If I go to, for instance, a 2D wireframe, how much tighter the triangles are where we densified versus where we didn't. Now that surface, if I go back and look at the statistics on it, now we're up to 253,000 points, but certainly significantly different than 6.4 million points. And if I don't want to continue in BricsCAD for some reason, if part of my workflow is that we use another design program, whether it's Civil 3D, Carlson, Bentley, you name it, we can just simply go back to the Home tab. We can go to Land XML, export Land XML, pick that surface, tell it where we want to export it, and save that file out. I could then take that Land XML file, import it into any other design software, and continue in our process. So what we really have the opportunity here to do is solve this very specific, very significant problem of how do we make an optimized surface out of point cloud data that is way too large, but we're not going to disrupt anyone's workflow. If they don't want to change their current workflow completely, they can just add BricsCAD to simply do this one process and then take the data into the program of their choice and continue. So those are the big things that we have on the civil survey and mapping side for V23. There's, of course, other things here as well, but I hope this gives you a good start. Thanks.